Hello everyone. Today we are going to solve the exercise 5 from the lesson number 5. The first question, choose the correct option. First one, what is the smallest prime factor of the number 75? As 75 can be divided by 5, but other than 5 before, 3 also can divide 75 as 25 3s are 75. Hence the option is B, 3. Second one, what is the least common divisor of the numbers 17 and 18? 17 is already prime number, so only two factors 1 and 17, and 18 is composite number. So here the option A, 1 is the correct option. That is 1 can be the common divisor between 17 and 18. The second question is state true or false. That is every prime number has only two factors. Yes, it is right. The prime number has only two factors, number 1 and number itself. Second one, the product of two prime numbers is always a prime number. Here one example is given. Two prime numbers 2 and 3. Their product is 6 and 6 is a composite number. So this statement is false. The product of two prime numbers is always a prime number. It is not right. The product of two prime numbers is always a composite number. Third one, sum. GCD is divisor of LCM. Let us take one example. Two numbers are there, 2 and 4. Their GCD is 2 and LCM is 4. And GCD is divisor of 4. That is 2 is the divisor of 4. Hence the statement is true. The fourth one, sum is LCM is greater than the given numbers or equal to the smallest number between those numbers. So here we will take one example that LCM of 2 and 4 is 4. And this LCM is equal to one of the number 4 equal to the greater number 4. In next example, LCM of 4 and 6 is 12 and 12 LCM is greater than 4 and 6. Hence the statement is false. The LCM is either greater or equal to the greater number. Question number 3. Express the number as product of prime factors. The number is 91 and 91 is equal to 17 multiplied by 13. That is 13 sevens are 91. 7 and 13 both are prime numbers and 91 is equal to 7 into 13 is the product of prime factors. The second one is 160 and 160 can be written as product of prime factors as 2 into 2 into 2 into 2 into 2 into 5. That is 5 times 2 and 1 times 5. Their multiplication. As 89 is a prime number, so 89 is equal to 1 into 89. Fourth one, find the GCD of the following numbers, that is greatest common divisor. The numbers are 21 and 42. By prime factorization method, we have calculated the factors of 42 and 21, which can be written as horizontally. 21 is equal to 3 7s are 21 and 42 is equal to 2 3s are 6, 6 7s are 42. So here 3 and 7 are the common factors. Hence the GCD is equal to product of common factors, which is equal to 3 multiplied by 7, and the answer is 21. Second one, for finding SCF or GCD, the numbers are 17 and 9. 17 is a prime number, so can be written as 1 into 17, and 9 is equal to 3 multiplied by 3. So as no common factor is there between 17 and 9, so SCF is 1 or GCD is 1. The third one is 120, 180 and 240. Here we calculated their factors by prime factorization method vertically. Now 120 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 into 5. Then 180 is equal to 2 2s are 4, 4 3s are 12, 12 3s are 36, 36 into 5. Then 240 is equal to 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 3s are 48, and then multiplied by 5. And the GCD is equal to product of common factors, that is 2 into 2 into 3 into 5. 2 2s are 4, 4 3s are 12, 12 5s are 60. Hence GCD is 60. Then the next question is find the LCM of the following numbers. They are 11 and 16. So by prime factorization method, 11 is equal to 1 into 11 and 16 is equal to 2 into 2 into 2 into 2, that is 2 2s are 4, 4 2s are 8, 8 2s are 16. So LCM is equal to product of common factors and uncommon factors. So all we have to write here all these factors and their multiplication is 176. So LCM is equal to 176. Second sum is 7 and 49. By prime factorization method, 7 is equal to 1 into 7 and 49 is equal to 7 into 7, that is 7 7s are 49. And LCM is equal to product of common as well as uncommon factors. Here common is 1 7 and others are 1 and 7, that is LCM is equal to 1 into 7 which is equal to 49. The third one is 16, 48 and 6, and by vertical layout method we have calculated its factors or their factors. For 16, 2 8s are 16, then 2 4s are 8, 2 2s are 4 and 2 1s are 2. For 48, 2 2s are 4, 2 4s are 8, then 12 2s are 24, 6 2s are 12, 3 2s are 6 and 3 1s are 3. And for 6, 2 3s are 6 and 3 1s are 3. Hence 16 is equal to 2 2s are 4, 4 2s are 8, 8 2s are 16. 48 is equal to 2 2s are 4, 4 2s are 8, 8 2s are 16 and 16 3s are 48. And 6 equal to 2 into 3. And LCM is equal to all these product of common and uncommon factors, which is equal to 48. The next question is question number 6. Solve the following. The first one, the product of two numbers is 120 and if LCM is 60, then what is their GCD? So we know the formula, product of two numbers is equal to product of GCD and LCM. Now we will put the values. So product of two numbers is given 120 equal to, then GCD we have to calculate, and then LCM is 60. Therefore GCD is equal to 120 divided by 60. So 61s are 60 and 62s are 120, or 0 0 get cancelled and 6 2s are 12. Hence the GCD is 2. Then the second one is the GCD of a number and 16 is 4. Means GCD is 4 and their LCM is 48. Then what is that number? Use the same formula. Product of two numbers is equal to product of GCD and LCM. So GCD given here 4, LCM is 48 and one number is 16. Now put the values. Put the values in the formula. Then we have a number is equal to 4 into 48 divided by 16. So 16 ones are 60, 16 threes are 48. So 4 into 3, which is equal to 12. Means that another number is 12. One number is 16, then another number is 12. The third one sum is, a carpenter has two wooden strips. The length of one strip is 54 inches and another is 72 inches. He wants to cut both the strips into equal lengths so that no wooden strip is left over. What is the maximum length of the strip that he can cut? So here the word maximum knowingly highlighted. For the word maximum, what we do? We calculate the GCD first. Hence, by vertical method of division or prime factorization, we will calculate the SCF or GCD for this 54 and 72. The factors for 54 are 2 3s are 6, 6 3s are 18, 18 3s are 54, and 72 is equal to 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 3s are 72. So the common factors are 2, 3 and 3. Their multiplication is 18. So SCF is 18. Hence, the maximum length of strips that he can cut is 18 inch. The fourth one sum is, Samip has 84 mangoes and 105 apples. He wants to place these fruits in boxes so that each box has the same number of fruits and each box contain only one type of fruit. So first one, what is the maximum number of fruits he should put in a box? For the word maximum we calculate SCF. The second one, how many boxes will he need to store fruits? Here Samip wants to make separate boxes of fruits and each box has the same number of fruits. And what is the maximum number of fruits he can put in a box? For that purpose we will calculate here SCF and we will calculate the count of fruits. Then we will calculate the number of boxes that he will need to store fruits. Firstly, we will calculate the SCF of this 84 and 105 by prime factorization method. Here the factors for 84 is equal to 2 into 2 into 3 into 7, that is 2 2s are 4, 4 3s are 12, 12 7s are 84. Then 105 is equal to 3 5s are 15 and 15 7s are 105. So the common factors are 3 and 7. SCF is equal to product of common factors, that is 3 into 7, 3 7s are 21. So here SCF is 21. So here we will get our first answer, that he should put 21 fruits in a box. For mangoes also, apples also. Now we will find out how many boxes will form after putting 21 fruits in a box. So there are total 84 mangoes. So 84 divided by 21 is 4. So he will need 4 boxes for mangoes and 5 boxes for apple, as total apples are 105 and divided by 21 fruits in each box. So 105 divided by 21 is equal to 5. So in total he will need 9 boxes to store fruits. Here our exercise 5 ends. I hope you understood the examples. If you find the content useful, please subscribe the channel.